All right, so let's now do some extra practice using the unit circle to evaluate trig functions, as well as cover using our calculator to check our work and get decimal approximations. Find the exact value of the following, then use a graphing utility to find the decimal approximation, round to 3 decimal places, and make sure your answers match. Always a good idea to be able to check our work using a calculator. All right, so this is asking us to evaluate the cosine of 7 pi over 6. Well, to do so, we need to identify the angle 7 pi over 6, which we have right here, and the corresponding ordered pair to that angle on the unit circle. And our definition for evaluating the cosine of an angle using the unit circle is cosine theta is equal to x. And so the x coordinate in this case is negative root 3 over 2. That is our final answer. Now we can check our work using our calculator. One thing to make note of, if the angles that you are dealing with are in radians, then your calculator needs to be in radian mode. If the angles you are dealing with are in degrees, your calculator must be in degree mode. Now, in this case, we are going to be talking radians. And in this class, most cases we'll be dealing with radians, unless we're talking about triangles. All right, so just double check to make sure your calculator is in the proper mode. Hit mode on your calculator, make sure it has radians highlighted, and select it if it's not. Now, all we have to do is type in the cosine of 7 pi over 6, and your calculator should spit out approximately negative 0.866. And if you were to type this quantity, negative root 3 divided by 2, into your calculator, you should get the exact same decimal approximation out. All right, these two values are close to the same thing. Why do we as mathematicians like negative root 3 over 2? Well, this is an exact answer. Compared to negative 8.66, well, we had to round. That is our decimal approximation. Okay, so exact answers, always better to give an exact answer when you can. However, we can check our work with a decimal approximation. Let's try another one. The sine of pi over 6. We identify the angle pi over 6 and the corresponding ordered pair on the unit circle. Our unit circle definition for evaluating the sine of theta is equal to y. The y coordinate of this angle is 1/2, therefore our answer is 1/2. Now we can go into our calculator. We type in the sine of pi over 6, again, still in radian mode, and we hit enter, and we should get out 0.5. And obviously, 0.5, same thing as 1/2. We know that we have the correct answer. The tangent of negative 2 pi over 3. So we must identify the angle negative 2 pi over 3. That means I need to rotate through an angle of 2 pi over 3. It's the equivalent of 120 degrees, but I need to do that in the clockwise direction. Notice all these angles start on the positive x-axis, and I need to rotate through an angle of 2 pi over 3 in the clockwise direction. That brings me to here. Theta is equal to negative 2 pi over 3, and the corresponding ordered pair, negative 1/2 negative root 3 over 2. Now, to evaluate tangent, our definition for tangent is y divided by x. The y coordinate, negative root 3 over 2, divided by the x coordinate, negative 1/2. I've got a negative divided by a negative. That's going to give me a positive value, and dividing by 1/2 is the same as multiplying by 2 over 1. Notice that when we rewrite this division as multiplication, we see that these 2's are going to cancel out, leaving us with root 3 for our final answer. Let's check our work in the calculator. We type in the tangent of negative 2 pi over 3 and hit enter, and we get approximately 1.732. And 1.732 is the decimal approximation of root 3. Check that by plugging in root 3 and hitting enter in your calculator. You should get the exact same value. The cotangent of pi. Well, let's find the angle pi. Here's our angle pi, and our definition for evaluating cotangent is take the x-coordinate and divide by the y-coordinate. In this case, x divided by y gives us negative 1 divided by 0. And negative 1 divided by 0, that's undefined. Yes, anytime we divide by 0, we are going to be undefined. All right, so let's see what our calculator does with this one. One thing to make note of, cotangent of pi. If you're using a TI-84, you do not have a cotangent button on the calculator. However, we can use the fact that cotangent of theta is the reciprocal of tangent of theta. Remember these reciprocal identities that we talked about at the beginning of the section of the chapter. Cotangent of theta is equal to 1 divided by tangent of theta. So that means to evaluate cotangent of pi in my calculator, I type that in as 1 divided by the tangent of pi. Plugging that in, our calculator will say error. Why does it say error? Because the value is undefined. We are dividing by 0. Cosecant of negative 5 pi over 3. This means that I need to travel through an angle of 5 pi over 3. 5 pi over 3 being 300 degrees. But because this is a negative angle, I want to go in the clockwise direction. Whoop. Brings me right up to here. There we have negative 5 pi over 3 for our angle, and the corresponding ordered pair is 1/2 comma root 3 over 2. Our definition for evaluating cosecant. Remember, cosecant is the reciprocal of sine. That's going to be 1 divided by the y-coordinate. Well, here's my y-coordinate, root 3 over 2. Remember, the quick trick for taking 1 and dividing by something is to just flip the fraction. We want the reciprocal of root 3 over 2, which is 2 divided by root 3. Remember, rationalize your denominators. We can do so by multiplying by root 3 over root 3, giving us 2 root 3 divided by 3 for our final answer. And let's check our work in the calculator. The cosecant of negative 5 pi divided by 3. Well, again, we don't have a cosecant button in the calculator. However, we know that cosecant of theta is equal to 1 over sine theta. They are reciprocals of each other. So to evaluate the cosecant of negative 5 pi over 3, I plug that into the calculator as 1 divided by the sine of negative 5 pi over 3. Hitting enter, we get approximately 1.155. And 1.155, well, that is the approximation of 2 root 3 divided by 3, our exact answer that the unit circle gave us out. All right, one more here, the secant of negative pi over 3. So we have to identify the angle negative pi over 3. I need to rotate through an angle of pi over 3. However, I need to do that in the clockwise direction. That brings me right down to here. There I have the angle negative pi over 3, and the corresponding ordered pair is 1/2 comma negative root 3 over 2. Our definition for evaluating secant of an angle theta on the unit circle is 1 divided by the x-coordinate. Well, 1 divided by our x-coordinate, again, that's just the reciprocal of the x-coordinate. That's 2 over 1, which is equal to 2. And in our calculator, the secant of negative pi over 3. Again, we don't have a secant button on our calculator, but we can use the fact that secant is the reciprocal of the cosine function. Secant theta is equal to 1 divided by the cosine of theta. So in my calculator, I type this in, 1 divided by the cosine of negative pi over 3, and hit enter, and we do indeed get 2. To check our work. All right, so there you have it, a little more practice utilizing the unit circle and evaluating trig functions, and also seeing how we can check our work using a calculator. All right, but again, always best to give exact answers when we can, only give decimal approximations if the problem asks you to do so.